Hi there, this is lecture 11. We are wrapping up chapter 9 and moving on to new things in chapter 10. Chapter 10 is all about integers, and we want to be able to represent them and then do all of our operations with them. So when we talk about integers, integers is the set of counting numbers, right? So the numbers 1, 2, 3, 4, 5. So our counting numbers, our technical term for that would be our natural numbers. They're opposites, meaning if I make them negative, right? And we want to throw in 0 as well. So that is 1, 2, 3, 4, 5 on up. Their opposites would be -1, -2, -3, and so on. And then also 0. That's our set of integers. So essentially we're working with negative whole numbers here. All right, so the first thing we're going to talk about quickly is context. So when you have positive numbers, the context or the situation or the examples that you have to create problems from is pretty much endless, right? You can talk about cookies and frogs and anything you want, right? But when you start talking about negative numbers, things that make sense as negative values are much more limited. So a lot of our problems tend to end up being about temperature, because you can have negative degrees, altitude, because you can be above and below sea level, yardage in games like football, right? You can go positive yards or negative yards, and money, when you bring in money or you lose money or you are in debt, okay? So, for example, during the game on Sunday, the Eagles started on their 10-yard line. If they gained 12 yards in the first play and went -6 yards on the second play, where is the ball now, right? So in that case, you can work in some negative numbers. How do we represent integers visually? So usually we do this in two different ways. We can use two colored chips, meaning you have little circles that are one color on one side and one color on the other. Usually they are red on one side and either white or yellow on the other, but it doesn't really matter what the colors are as long as you have one that represents positive and one that represents negative. So usually when I draw this as red and white. Or red and black too as well you could go with. But so my reds look like this. And my black look like this, right? Or sometimes we can make them more white. So they look like this. Although that can be harder to see. So whatever you're working with. Okay, so two color chips. So you can make them red, you can make them white. If you don't have colors, a nice way to do it is to make them positive. Oops, let me change that back to black. You can go positive or you can go negative, that kind of thing. Make sure that if it's not clear, meaning you have pluses or minus, and if you're using different colors, make sure that you give me a little key somewhere that says, okay, well, the red ones are my negatives and my white ones are positive. That way I know how to interpret whatever your picture is. The next thing is that I'm going to be asking you for explanations with these. And so when you do that, I want you to talk about chips. We don't talk about numbers anymore. We talk about chips, right? So we're going to have red chips and white chips, and we're going to do things with our red chips and white chips. We're going to combine them. We're going to take things away. Okay, so be aware that when we're writing our explanations about our chips, we're talking about our chips and using that language. Okay. Now, the first thing we want to talk about when it comes to chips is the idea of a zero pair. And a zero pair is a pair that makes 0. So that means I want one red and one white makes a 0 pair. And that's because together you have a positive one and a negative one and they cancel each other out. So this is just 0. And that means that to any number of chips that are on the table, I can add in as many 0 pairs as I want and still have the same number, right? So if I have something that looks like this, right, that would be the number -3. And let's say I add in a 0 pair. That's still -3 because my 0 pair zeroes out and I only have 3 negatives. I can add as many as I want, right? As long as it's a 0 pair, they don't contribute anything, right? This part here is all 0 because it's 4 0 pairs. And then you have 3 red chips left, so that's -3. So those are all representations for -3. Our second option for representation is a number line, and this is exactly what you think a number line that looks like this. Typically, we get our 0 in the middle. 1, 2, 3 over here. -1, -2, -3. So -3 here would be this spot right here. Okay, so we're going to use both as a way to represent our integers as well as to help us with our addition and subtraction. Okay. So now we got to think about what we're going to do with operations. So how do we operate, or how do we add, subtract, multiply, and divide using our chips and our number lines?
All right,
so here we go. We're going to start in with a problem like -3 plus 8. Okay, so for addition, when we had positive numbers, do I have positive numbers here? I don't. So let me give you a little example real quick up here. So when we had positive numbers like 3 plus 4, we would say, okay, well, give me 3 things, and then give me 4 things, and then combine them together, right? And we would add them up. So then we're going to start out with a similar technique here. So when we see -3 plus 8, we're going to start out by representing the -3. So I'm going to have 3 red chips to represent -3. Then I'm going to put down 8 white chips to represent positive 8. The plus sign means combine, so I put them all together. And then what I'm going to do is I'm going to match up any 0 pairs. So here's a 0 pair, here's a 0 pair, here's a 0 pair. They all match up to be 0. So what's left are my 5 white chips that are left. And so my answer to the problem -3 plus 8 is going to be 5 white chips. Well, white chips are positive, so that's positive 5. Okay. So that's what we do. With addition, we combine things. Okay. On the number line, okay, and you're going to give me words that go with this. So the words that go with this, and I'm not going to write in full sentences, but you are. This would be something like we represent -3 with 3 red chips. Notice that I'm talking about the chips. I represent, here we'll use proper notation, make this a little r. I represent I, or typically in mathematics we use we. We represent -3, we represent, but I is fine as well. We represent the 8 with 8 white chips. We combine them, since that's our addition, and match up any 0 pairs. There are 5 white chips left. So my answer is positive 5. Now, you don't have to write the plus 5. You can just leave it as regular little 5. That's fine. Okay, but that's what I'm looking for. I'm looking for complete sentences. I'm looking for good punctuation. I'm looking for you to say, here's what I did. I represented this. I represented this. I did this with them. Here's how I found my answer. Okay. On the number line, we are always going to start from 0. So my starting point is going to be at 0. So if I'm jotting down what I'm doing, I'm going to start at 0. Actually, I'm not. Sorry, I lied. Let's fix that. We're not going to do that. Where are we going to start? We're going to start at the first number. So that means we're starting at -3. And we need to add positive 8. Okay, so here's the key thing that's going to happen. We're going to start at the first number. We are going to take a look at the second integer. In that case, that second integer is positive. So we are going to look in the direction of the positives. right? Now, the reason for that is because what we need to do is we need to be able to compensate for both adding positive negative numbers and subtracting positive negative numbers. So if all I do is talk about moving left and right, that only gives me two options. But I can add a positive, add a negative, subtract a positive, or subtract a negative. And that's four different things. And so what I need four different options. So what we're going to talk about, instead of just moving left or right, we're going to think about looking one direction or the other and moving forwards or backwards, right? So imagine that you're standing right on my number line. You can either look to the right where the positive numbers mostly are, or you can look to the left where all the negative numbers are, or most of the negative numbers are. And the way you determine what direction you're going to look is by looking at the second number. So my second integer is positive. So I'm going to look where most of the positive numbers are. So that means I'm going to look in the direction of that arrow. Okay. So if I'm standing on my green dot facing the positive numbers, right, then either I can move forwards towards the positive numbers or in the direction of my arrow, or I can move backwards opposite the positives and opposite my arrow. Okay. When we are adding, we are going to move forwards. Okay. That way subtraction will move backwards. Okay. So we're going to look in the direction of the positive numbers because of the positive 8, right? We are going to move forwards because we are adding. And again, you're going to turn this into full sentences as an explanation for me. And we're going to move that number of spaces. So we're going to look at the positive numbers and we're going to move in the direction of the arrow 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. And I land on positive 5. Okay, so my answer is positive 5. Okay. So if that confused you, just hang tight. We'll do a couple more examples and see if we can get help you understand clearer. So let's look at the next one. So 5 plus negative 2. So in terms of chips, I'm going to start by representing the first number. So I'm going to represent the 5. So I'm going to have 5 white chips. And then I'm going to represent the second number. I'm going to represent the negative 2 with 2 red chips. Addition means combine, so I look at all of these together, and I match up any 0 pairs. So that's a 0 pair, and that's a 0 pair. Those are all 0. And so now what I have left are 3 white chips. And so 3 white chips left. So 5 plus negative 2 is positive 3. Right? And then you would answer, write an explanation as to what you did. We represent the 5 with 5 white chips. We represent the negative 2 with 2 red chips. We combine them all together because we're adding. We match up any 0 pairs, and then we have 3 white chips left. In terms of the number line, okay, you're going to start on the first number. So you start at 5. We are going to look in the direction of the second number. So again, you're taking 5 plus negative 2. Okay, so that means we're going to look in the direction of the sign of this number. So negative 2, we're going to look at the negatives. The addition says that we move forwards. Right? The addition is our action piece, and so we're going to move forwards in a positive way. And my answer is where I land. So let's do that. So if I'm color coding here, by the way, the looking at the negatives comes from the negative 2, and the moving forward comes from the adding, okay? So I'm going to do exactly what it says. So I am going to start at positive 5. I am going to look at the negatives. So the negatives are this direction. And I'm going to move forward, which is in the same direction as my arrow, 2 times because my second integer is 2. So 1, 2, and I end up at positive 3. So my answer is 3. Okay, let's take a look at this one. Negative 3 plus negative 5. For chips, I'm going to start out by representing both values. So I represent negative 3, with 3 red chips. I represent my negative 5 with 5 red chips. I combine them all together, and I have 8 red chips. There are no 0 pairs, so we have 8 red chips, which means -3 plus -5 is -8. On the number line, we're going to start at -3. We are going to look in the direction of the second integer. Now, the second integer is -5, so we're going to look at the negatives. We're going to move forwards because we are adding. And our answer is where we land. Okay. All right. So, again, we are starting at -3. Right here. Oh, wait, that's +3. Let's start at -3. There we go. We're going to look in the direction of the negatives. So the negatives are mostly over this direction. So we're going to look there, and we're going to move forward 5 times. So 1, 2, 3, 4, 5, and we land right here on -8. So -3 plus -5 is -8. Now, same kind of thing happens when it comes to negatives. The number lines, we're just going to, instead of moving forwards, we're going to move backwards when we subtract. And the chips, instead of combining things, we're going to try to take things away. Okay, now that can be easier said than done. So let's see how that's going to play out. Okay, so we have 6 minus -4. Now, when we added, we represented both numbers. When we subtract, we're only going to represent the first one. So I'm going to start with the 6. It's +6, so I'm going to represent that with 6 white chips. Okay, now subtraction means take away, or that's one of the interpretations of subtraction. So we want to take away -4. Well, -4 is 4 red chips. So what we need to do here, we need to take away 4 red chips. But I only have 6 white chips, so I can't do that. Well, I need to create a different version of 6 that allows me to take away 4 red chips. Well, I can do that by adding in 0 pairs. So if I put in 4 0 pairs, right, I still am starting with a representation of +6, right? The 0 pairs are 0, and I have 6 white chips. But now I do have 4 red chips on the table that I can take away. So I'm going to go ahead and take away those 4 red chips. What I'm left with, I have 10 white chips. So that implies my answer is +10. Okay, so when we don't have what we need to take away, we put in 0 pairs until we can't do it. Okay, that's the key thing with chips. Number line, this is going to go the same way, only instead of moving forwards, we're moving backwards. So we've got 6 minus -4 here. So we're going to start at the first number, so start at 6. We are going to look in the direction of the second integer. So this is -4, which means we're going to look at the negatives. Okay. Subtraction means that we're going to move backwards this time. So this subtraction right here tells me that I'm going to move backwards. So let's do it. So let's start at 6. So 6 is over here. We're going to look at the negative numbers. So the negative numbers are this direction. But now we're going to move backwards. So backward means opposite your arrow. So we're going to go back 4. 1, 2, 3, 4. And we land on +10. So your answer is +10. Just as it was above. Okay. So that's how we're going to work subtraction. We're going to use take away, And we can put in as many 0 pairs as we need until we can take things away. And when it comes to number lines, we're going to move backwards as opposed to forwards. Let's look at 2 more examples. Okay, so -2 minus 6. So this says we're going to start with -2, and we're going to take away +6. So we're going to take away 6 white chips. That's what I need to do. Okay, so I'm going to start out with the first, representing the first number. So I'm going to represent -2 with 2 red chips. And I'm going to try to take away 6 white chips, but I don't have any. So that means I need to put some in. I've got to put in 0 pairs until I can take away 6 white chips. That means I'm going to need 6 0 pairs. Okay. Now I still have -2 because I have 6 0 pairs that are 0 and those -2 that make 2 red ones that make -2. But now I can go ahead and take away these 6 white chips. And when I do that, I'm left with, let's see, 6, 7, 8 red chips. So my answer is -8. Okay. And again, you're going to write out some sentences that tell me exactly what you did. It would go something like this. We start with 2 red chips. We want to take away 6 white chips, but we don't have any. So we put in 6 0 pairs, then take away 6 white chips, and we're left with 8 red chips. Okay. For the number line, we're doing -2 minus 6. So we are going to start at -2. We are going to look in the direction of the second integer. So you are subtracting 6, that's +6. So we're going to look at the positive numbers. We are going to move, you are subtracting, so we're going backwards. Okay. So if we do that, we're starting at -2. We are looking at the positive numbers. The positive numbers are in that direction, and we're moving backwards, so opposite our arrow. We're going to go 6 times. 1, 2, 3, 4, 5, 6, and we get that same -8. So answer is -8. And again, you're going to turn those little notes that I made into full sentences so you can explain what you did. Number 6. We have -3 minus -2. Okay, so I'm going to represent the first number. So I'm going to represent the -3. So I get 3 red chips. And what I want to do is this is subtract -2. So I want to take away 2 red chips. So I'm going to go ahead and take 2 of these red ones away. I have them, so I can take them away. And I'm left with 1 red chip. So my answer is just +1. -1 because it's red. Okay. Okay, now just to let you know, I know that your rules that you have from elementary school are that subtracting a negative becomes positive, and on add a line, change a sign, and all kinds of rules that you've got. But what we want to do is we want to stick to our representations. Okay, we don't want to change the problem. We want to use our representations to get an answer to the problem. And then we can look at what happens and see if we can get shortcut rules. Okay, so in this case, for the number line here, we're going to start at -3. Because that's our first integer. We are going to look in the direction of the second integer. My second integer is -2, so we're going to look at the negatives. And we are subtracting, so we are going to move backwards. Okay, and so that means we're going to start out at -3. We are going to look at the negatives. Most of the negatives are in that direction. And then we are going to move opposite that arrow. We're going back 2 spaces. 1, 2, and we end up at -1. So our answer is -1. Okay. All right, and that's going to end our first part of the lecture. So that's part 1. Check out the other video for part 2.